Alright, in this video I'm going to show you how the binomial distribution has a function within Google Sheets to help calculate its probability. It's exactly the same in Excel. And to get started, we're just going to use the example we were working with in class. We're planting 5 seeds. The chance that a seed germinates is 0.7. And you could have outcomes for the random variable being the number of seeds that germinate, that none, or 1, 2, 3, or all 5 of them germinate. And then you've got the respective probabilities for each of those discrete cases. Here, exactly 3 germinate. Here's the probability that none of them germinate. I'm going to go ahead and take this table and I just transpose it. Here's now the outcomes of the number of seeds germinating, and here are the respective individual probabilities for each of those discrete cases. Ignore the cumulative manual column here in blue. Now, the thing that's fancy about, and it'll help you quickly solve problems on quizzes or tests, is that you have to remind yourself that the table was given to you here, right? So you were given a table already filled out. You could be asked a question on the test or quiz that gives you just the following things. Here's the chance of a success, and you have so many trials, being 5, and then they just ask you a question, what's the chance that at most 2 seeds will germinate? And notice you don't have any table built for you in the question. It just gives you the chance of a success, the number of trials, and then it asks a question. And so you've got to use, you do not want to sit there and reconstruct this table. That's a waste of time. And in some sense, looking at a chart opens up its own problems, in that you may copy something incorrectly or put it into your calculator incorrectly if you're to use a table in the back of the book. So using this function is pretty handy dandy, but if you don't use it correctly, you could get a probability that's going to be answering a different question than the one that you're given. So what we're going to do is I'm just going to show you how it works by reconstructing the table here for the individual probabilities for each of the discrete cases. So we're going to hit equals, and we're going to select the equal bin, and we're going to come up here and select this binom dist function. Hit that question mark to open up the arguments here. So it wants a couple of things. It wants the number of successes first, the number of trials second, the probability of a success third, and then it's got this inherent function inside of it being cumulative that you have to either turn on with a true or turn off with a false, and I'll explain how that works. Let's look at the true case. Let's look at the false case to begin with. So it wants the number of successes. Let's select that cell over there. It wants the number of trials. We know it's 5. We are also given the chance of a success, and let's turn the cumulative function inside of it off by typing false. We can see that that value for a probability matches that one. If we stretch it, we get all matching probabilities that are over here for the discrete cases. So that's great, but that's using the case of false. So what does true do? To understand that, we need to look at the cumulative function, and we need to probably see it in the case where we're asking this question, what is the chance that at most 2 seeds will germinate? Well, expanding that into a statement of probabilities, that's the chance that the random variable could have none of the seeds germinate, or 1, or 2, at most, right? 2 seeds germinate. So it's each of these 3 discrete cases satisfies that question. We know that's a compound probability of an OR statement, so we can open up and sum the individual probabilities that none of the seeds will germinate, plus 1 seed will germinate, plus the probability that 2 seeds will germinate, and then someone's out there asking, well, we need to subtract the case that the conjunction takes place where we could have none of the seeds germinating, and 1 of them germinating, and 2 of them germinating. And you should see that these are mutually exclusive events in a discrete probability distribution. You can't have simultaneously none of the seeds germinating together with only 1 and together with only 2 seeds germinating. So that goes bye-bye, and you're left with just looking at the individual sum, the sum of the individual probabilities that none or 1 or 2 of the seeds could germinate. Now, that would mean we'd have to sum this cell here, this cell here, and this cell here. Well, that's what that right there is doing. If you double click it, it's the sum of B6 through B8. So it is the sum of the individual probabilities that none or one or two seeds will germinate, which answers the question here, the chance that at most two seeds will germinate. And if you think about it, we know the fact that in a discrete probability distribution, if we sum up all of the discrete cases of probabilities, all the discrete cases and their associated probabilities, that we should get 1 as the answer. And that's what's taking place here. If you select that, you can see it's summing up all the individual probabilities for the discrete cases, and voila, it's a legitimate probability distribution. Okay, let's do that using the binomial function in Google Sheets here. So binom dist, and so we're going to select that being the number of successes. We have 5 trials. We have 0.7 as a probability, and let's turn on true now for that cumulative function inherent to this binomial function in Excel. Expand, and we can see that voila, we get the same values. Here we have at most 3 seeds germinating. It matches that when we've turned on the cumulative function to be true within the binomial distribution function in the Google Sheets. Good. So coming down, let's now answer. I've already got it done here. You can see I've made this video several times, and by making one mistake, I gotta remake the whole thing. All right, what is the chance that 3 seeds will germinate? So notice it doesn't give you at most, at least, or anything. What's the chance that 3 seeds will germinate? Well, that's the answer right there, 0.3087, right, for that column of discrete probabilities. But let's say we weren't given that. So all we have is the chance of success, the number of trials, and that's it. And then it gives us this question. What's the chance that 3 seeds will germinate? So equals binom, hit that binom dist. Now we'll come in and fill up. We have 3. We have, sorry for my dog snoring here. Let's wake her up. She kind of, sorry. We have 3 successes, we have 5 trials, we have a 0.7 for a success to take place, and we don't want it to cumulatively sum all prior cases, or probabilities rather, so we want false. And we can see that matches that probability right there. What is the chance that at most 3? So at most 3 means that you could have none, or 1, or 2, or 3. So that is a cumulative function turned on. So equals, and do the bin, dist, 3. Let's have 5 trials, 0.7 as a success, and let's turn the summing function on, and we can see that there it is. The chance that at most 3 seeds will germinate is almost 50%. What's the chance that at least 3 seeds will germinate? Now that's a little different. That is the chance that exactly 3 or exactly 4 or exactly 5 will germinate. Now notice the binomial distribution function only sums a particular probability for a discrete case in all prior cases. So for this value here, it's taking that probability and summing together all prior. We want to take the case where we want 3 seeds to germinate and then all subsequent probabilities to be summed together. All right. Now to do that, we're going to have to use the fact that if you take what's the chance that at most 2 will germinate, plus together with its negation, that would be at least 3 would germinate, we would get equal to 1. Now I hope I said that correctly. What's the chance that at most 2 will germinate? That's this probability, which is the sum of these 3 cases, together with a negation that at most 2 will germinate, which means that at least 3 will germinate, which is the sum of those 3 cases. We know that we've summed then all the individual cases up, we should get 1. So what I'm trying to say here is that what's the probability that x is going to be less than or equal to 2 plus the negation of that, which is the probability that x will be more than or equal to 3, that is going to equal 1. The binomial distribution will only find for us that. It will not find for us the answer to the question that at least 3 seeds will germinate, more than or equal to 3. So remember, solving this, let's go over here. We can actually see this. If we were to solve for this right here, this term, we would end up getting this back. We would get the probability. Oops, well, we can work with that. Whoops, sorry. There we are. We've solved for the probability that at least 3 seeds will germinate. There we are. And that's equal to 1 minus the chance that at most 2 seeds will germinate. Good. So let's type this into our cell, and knowing that we can actually put this into the binomial distribution function for Google Sheets, but this one we're going to have to leave. We can't solve that directly using the function inherent to Google Sheets or Excel. So what we'll have to do is equals 1 minus probability. And it's always good, I'll tell you the truth. Let me get out of this for a second. I would write that down on your paper, okay? And I would then look at this piece and use that to put into the cell down here, or else I might get something wrong. And you can see what's going to take place is that it's going to be equals 1 minus bin dist. We look over here, the number of successes are going to be 2, trials 5, chance of success 0.7, and we do want to sum up. Alright, so what's the chance that at least 3 seeds will germinate? That should equal the sum of 3 or 4 or 5, all of those. And we can see that it matches. So you've got to take the probability that you could have at most 2 away from 1 in order to use this function correctly and get the right answer in Google Sheets. What is the chance that more than 1 seed will germinate? Well, more than 1 would mean that you get 2 all the way up to 5, which means you need to sum all these up, right? And so the probability that more than 1, x more than 1, is going to be equal to 1 minus the probability that x is less than or equal to 1. Right? So the chance that you'll have more than 1 seed germinate is 1 minus the chance that you'll have less than 1 seed germinate or exactly 1 seed germinate. And so putting that into the calculator, we have equals 1 minus bin dist. We want 1. We want 5 trials, 0.7 success, and we do want to sum up in that case. And so you can see what's the chance that more than 1 seed will germinate? That should equal the sum of here to here, and you can see that's the case. What's the chance that less than 3 seeds will germinate? That's equal bin, that's outright. Less than 3 would be that you have 2 successes. You've got 5 trials and 0.7 as a success. Oops, and you do want to, since it's strictly less than, You want 2 or 1 or 0. Whoa, what happened there? Oh, I didn't select the right function. Dist, is that it? Oops, we'll have to redo it here. Just give me a moment. Binom dist. Binom. There we are. So what's the chance that less than 3 seeds will germinate? That's equal to the sum of here, and see that matches 2. All right. So, you know, I'm using the sum function to get that probability, that one, and that one. But, you know, that's only because I actually have the chart built. If you don't have the chart built, well, then you're going to have to use the binomial function together with 1 certainty to figure out the answers to the question. In Excel, it's similar. If you come over here, it's just written differently. So look at this case here and here. So let's see here. If we wanted to find the individual probability that, scoot it over some more, that only 2 seeds will germinate, so it'd be binom dist. That's correct. Notice that it wants the number of successes. We only want 2. Number of trials 5. Probability 0.7. And then if you want only 2 and 2 only, then you don't want the cumulative function turned on. You want it to be false. And you can see that that value there matches that value there. And then if you want a cumulative, so if you want at most, or I'm sorry, at most 2, binom dist, number of successes is 2, trials 5, probability 0.7, and then if you want at most 2, then you want 0 or 1 or 2, so you need this to be turned on. At most 2 would be the sum of these probabilities, so the answer we're getting in Excel over here matches that cumulative probability for this discrete probability distribution. So that's how that works. I hope this helps. You can do it on the TID3, but then again, you don't have to spend $100 because you've already got this stuff built into your laptop. You can choose your poison as to what you want to use on the test or quiz, but just be careful in defining the question clearly through the binomial distribution function. Otherwise, you may get something that's an answer, but it's not the answer to the question that you want. Okay? I hope this helps.